Hello, my name is Ethan, and we are doing some quiz question revisions for the initials A N. That is not a very good A, and I think I've made it worse. Either way, let's go on to the first one here. This is question 2 of 27.5, 27.6. So Jeff takes 5 hours longer to build a fence than Bill. When they work together, it takes them 6 hours. How long will it take to Bill to do the job alone? So first thing I see is Jeff takes 5 hours longer than it takes to build a fence. Jeff takes 5 hours longer to build a fence than it takes Bill to build the same fence. So let's define two variables. B is going to be time Bill takes to make the fence, and J is going to be the time Jeff takes to make the fence. So we know that Jeff takes 5 hours longer to build a fence than it takes Bill, so meaning that J is going to be equal to 5 plus B, because it takes 5 hours longer. So Bill is quicker, so in order for Jeff and Bill's times to add up, we have to add this 5 to Bill's faster time so that they're equal. So this is true. When they work together, it takes them 6 hours. How long will it take Bill to do the job alone? Okay, so this is a speed question. So these are all speeds, basically. So we have one fence, and it's going to take, this is Jeff's time. It's going to take Jeff. Well, let's do Bill. Bill, so, yeah, so it's going to be one. So speed is always distance over time. So, or length over time. In this case, our length is a fence. How long does it take until we or how fast can they put up the fence? So that's going to be putting up one fence over however long it takes Bill to do it. So in that case, B, plus Jeff's time. So that's one fence over Jeff's time. So that's going to be J. But remember, we just figured this out. So we can actually substitute in 5 plus B for J. And then it also says that if we combine Bill's speed and Jeff's speed, it takes them 6 hours to do it. They can put up one fence in 6 hours. So then all we have to do is solve for B there. Now, first thing I would do is I would multiply everything by 6. So multiply both sides by 6. We distribute the 6 into the brackets here. So this becomes, I'll write this down over here, 6 over B plus 6 over 5. Ooh, there we go. 5 plus B equals 1. Simplified a little bit there. Then what we can do is, excuse me, what we can do is let us rewrite this 1 in terms of B. So if we multiply by B over B, this is going to be 6 over B plus 6 over 5 plus B is equal to B over B. Great. So now if we subtract both sides by 6 over B, I'm going to move this work just so that I have a little bit more space. Just move it up here. Subtract both sides by 6 over B. This side right here is under the same denominator, so then we're going to get 6 over 5 plus B is equal to B minus 6. over b. And now what we can do is let's multiply both sides by b. But let's also multiply both sides by the 5 plus b. Just get rid of the denominators. So 5. So maybe I should specify, or I'll do it up here. There we go. Great. So then our new equation is going to look like, well, b's cancel out over here, and 5 plus b's are going to cancel over there. So we're going to be left with 6b is equal to, that's going to be b minus 6. And since 1 plus 2 is the same thing as 2 plus 1, we can rewrite 5 plus b to b plus 5, cumulative. And then we just need to solve for b. This looks like a pretty classic quadratic here. So we can do 6b is equal to b squared. That's going to be b times 5, 5b, minus 6b is minus 1b, minus 30. And then just draw some arrows because we're a little bit running out of room. We can minus both sides by 6b, so that this becomes 0 equals b squared minus 7b minus 30. Perfect. Now, this is just simple factoring. So 0 is equal to b times b. And we're looking for two numbers. I'll do our chart up here. Two numbers that multiply and make negative 30 and add together to make negative 7. First two couplets that come to mind are negative 10 and 3 and negative 3 and 10. Looks like this top one adds up to negative 7 and also multiplies to negative 30. So that's going to be our choice there. So negative 10 and we minus 10. So then this is going to be minus 3 or plus 3. So in this case, Bill's time can either be 10 hours or 3 hours, or negative 3 hours. Now, again, looking at the context of the question, it's asking about time. Time always has to be positive. So in this case, we can disregard the negative 3 solution, and b has to be equal to 10. So this is going to be your answer, 10 hours. Okay, so this is question 3 of 27.5, 27.6. A boat goes 400 miles downstream, the same time it takes to go 350 miles upstream. The speed of the current is 9 miles per hour. Find the speed of the boat in still water. Perfect. So, well, first thing I'd like to do is let's write out our speed is equal to distance over time formula. And what's important here is that we should rearrange for time, our t, so that we get distance over velocity, because it's going to be very helpful in the later parts when we're solving the algebra. So, we've got let's consider two different times. So we've got the time it takes for us to go downstream. So it's going to take us 400 miles. If we go 400 miles downstream, and our speed, since we're going downstream, we have to add the speed of the current to our x being our speed of the boat in still water. So it's going to be x plus 9. Now let's consider the time it's going to take to go upstream. So we go 350 miles upstream. But in this case, the speed of the boat is being hurt. It's being detrimented by the current. So it's going to be minus 9. Now what's important is that these two t's are the exact same. So notice it says a boat goes 400 miles downstream and 350 miles upstream in the same time. So these two t's here are equal. So therefore, we can rewrite the equations to look something like this. Now, when we've got this new equation here, what we should do is we should multiply this side by x minus 9 and this side by x plus 9 as to get rid of the denominators in the corresponding functions. So this is going to be 400 times x minus 9, because we're multiplying this side by x minus 9. We're going to multiply this side by x minus 9. And we're multiplying the other side here by x plus 9. Perfect. And then carry the 400 over. So that's going to be 400x. Got my calculator here. What is 400 times 9? That's 3,600. And then 350 x. And then what is 350? Ooh. 350 times 9 is 3,150. Great. I'm going to subtract both sides by 350x. So we're going to get 50x on this side. And I'm going to add 3,600 to both sides. So 50x is alone on this side. And then we add 3,600 to 3,150. And we're going to get 6,750. And then divide both sides by 50. We're going to get 135. Perfect. So we look over here. Looks like we got 135. And that's, remember the units, that's miles per hour. So this is question 4 of quiz 27.5, 27.6. A loaded truck is moving 20 miles per hour faster than a freight train. In that time, it takes the train to travel 120 miles. The truck travels 200 miles. Find the speed of the truck. So, first thing, let's look at this sentence here. A moving loaded truck is moving 20 miles faster than a freight train. Meaning that if F is our speed of the freight train, we have to add a speed of 20 miles per hour to it to equal R, the speed of the truck. So we've got that nice equation there. And what we can do is we can solve this for in terms of F. So F is going to be equal to 20 minus, or R minus 20, excuse me. Great. Okay, we have that in mind. Now, let's remember our V is equal to D over T formula. And let's solve for T. So in this case, we multiply both sides by T and then divide both sides by V. We get T is equal to D over V. Great. And now, it looks like we've got two different distance over speeds. In this case, we've got the one of the train. So our train has to travel 120 miles, and they're going a speed of F. But let's write, instead of writing just F, let's write this R equals 20 that we figured out earlier. And our other D over V is going to be the time of the truck. So the truck is going to goes a distance of 200 miles, and they just go R, the speed of the truck. Great. Now, if you read the question again, slowly, it kind of implicitly states that the times that it takes the train to travel 120 and 200 miles, going their speeds F and R, are the same. So this T is equal to this T. And in that case, we can just write both equations equal to each other, which makes our lives a lot simpler, because now all we have to do is solve for R being the speed of the truck, and we've got our answer. So let's multiply both sides by R. Great. And let's multiply both sides by R minus 20. Now, let's just expand that right-hand side there. That's 200R minus 4,000. Great. Let's add 4,000 to each side. So 4,000 over here. And let's subtract 120 from each side. So we get 80R. And if we divide both sides by 80, we figure out that R is going to be 50 miles per hour. If you look at our answers here, we got a 50 miles per hour. Awesome. Last one here. This is question 5, 27.5, 27.6. Excuse me. So Chuck and Dana agree to meet in Chicago for the weekend. Chuck travels 192 miles in the same time that Dana travels 183 miles. If Chuck's rate of travel is 3 miles per hour more than Dana's, and they travel the same length of time, they're really hitting you home here. What is the speed that Chuck travels at? So let's first look at the relationship between Chuck and Dana's speeds. So Chuck drives 3 faster, so C for Chuck, meaning that D for Dana, meaning we have to add 3 to Dana's speed to make it so that Chuck and Dana's speeds are the same. So we get this formula there. And in this case, I know... okay, well, let's just keep going. So then this is also another one of those... we've got our V equals D over T. Solve for T. And then we've got 2 different ratios here. So we got Chuck's distance over velocity, distance over speed. So Chuck goes 120. This is equal to T, excuse me. And Chuck goes speed C. Great. And in this case, let's try the other way. So we know that C is equal to D plus 3, so we can just substitute in D plus 3 here. Great. Then we also know that T is equal to 180. This is Dana's speed over D. And again, as it explicitly states here, same length of time, same length of time. So these 2 T's are the exact same. So therefore, we can write them both equal to each other. And now we just have to solve for D. D being Dana's speed, but up here, remember, we've got this formula, so we can take Dana's speed and turn it into Chuck's speed. So, multiply both sides by D, and then multiply both sides by D plus 3. Solve this side here, so that's going to be, oh geez, 183D. Let me get my calculator out here. Ooh. That is going to be 549. Subtract 183D from both sides. We're going to get 9D is equal to 549. Divide 549 by 9. D is equal to 61. But remember, D is Dana's speed. So what we have to do is we have to put in this formula to solve for C, which is Chuck's speed. So, well, that's pretty simple. We just add 3 to Dana's speed, and we get Chuck's speed. So 3 plus 61 is 64.